What I want you to do right now is to go ahead and take these 4 on the left side and the 4 over here on the right side, type them into the calculator to see which ones are right or wrong. Well, when you do that, you'll realize that the first one is not true. The second one down on the left, yes, that is true. The third one down on the left is false. The bottom one down here is also false. On the right-hand side, this one is false, but you realize the second one is true. The third one down is false, but the last one down is true. Well, we can use this to help us come up with what's going on. Here you had the log of two things multiplied, and you could write it as the log of the first one plus the log of the second one. That's what we're doing down here. When you have the log of two things multiplied, you go log of the first one plus log of the second one. Over here, where you're dealing with two things being divided after a log, you got to go log of the top one minus log of the bottom one. And that's what we're saying. Log of the top one minus log of the bottom one. When we look at the lower two here, we have log, or an exponent after a log here, and we could really just take and put that exponent down in front. So we're going to take our c, put it down in front, and that's what this rule is saying we can do. Now, a lot of people seem to think that we can take our log and distribute it through to each one when there's a plus or a minus sign here, or even when there's multiplication inside. But in reality, you can't. For this one over here, when you have two things added after a log, you can't do anything to change it. So we're going to use those properties of logarithms, and by the way, these three properties of logarithms right here, you're going to need to make sure you know. You're not going to pass your test if you don't know those. We're going to use those properties of logarithms to help us to approximate log base 5 of 250. The only thing we know is log base 5 of 2 is this number. So you need to think, is there any way I can rewrite 250 with 2's? Well, when you're thinking of 250, that you know that that is 2 times a 125. However, the 125 is helpful to us because it's going to be a 2, and a 125 is a 5 to the third power. It's nice to have it as a 5 because we're dealing with base 5, and that helps us out. So we're going to rewrite our log base 5 of 250 as a log base 5 of a 5 cubed times 2. You now have it written so you have two things multiplied after a log. When you have two things multiplied after a log, according to the rules on the previous slide, you can go ahead and go log of the first part, and then you go plus log of the second one. Well, we know the decimal approximation for the second one, because that's exactly what we have up here. So this part here matches with what we have up here. Well, we want to look at this. In that case, it's just 3. And you might be wondering why. Well, remember, this means your base of 5 to what power equals what's afterwards, which is your 5 cubed. Well, the only way that can happen is if that power is your 3. So then you take your 3 and you add it to this, and you get 3.4307. Same approach down here. Here we have log base 6 for each one of these, and one of them's of an 8, and one of them's of a 32. So you want to think, okay, is there any way I can rewrite my 4 here in terms of either 6 or 32 or 8? Hopefully you remember your facts, and remember that 32 divided by 8 is 4. So instead of writing my 4, I'm going to replace it with a 32 divided by 8. I'm going to use the 32 and the 8 because I know information about that, according to what I have up here. Now I have this written as the log base 5, or log base 6 of 32 divided by 8. When you have two things divided after a log, you can break it apart and go log of the first one and then subtract log of the second one. Since we know exactly what this is, we can plug that in. And since we know exactly what this is, we can plug it in. And then all we have to do is just subtract those on our calculator. On the bottom one down here, the only thing you know about, or you're given, is a base of 5 and a 6. So you got to think, is there any way I can rewrite my 216 with 5s or 6? And in this case here, 5 isn't going to help you. But 216 is a perfect cube, and it ends up being 6 cubed. Now we have an exponent after a log. You should remember with an exponent after a log, you can take that exponent, put it down in front. We now have log base 5 of 6, but we know log base 5 of 6 is this number here, so we can take our 3 in front, times this number up here, and then we multiply that out and we get our answer. So let's go ahead and solve these. To solve these, we're going to go ahead and combine these two logs together. Notice we have a log plus a log. And one of the properties that we talked about said, if you have a log plus a log, you can combine them together in one log and just multiply what's afterwards. So we're taking and we're multiplying these two things together. So a log plus a log you can combine together by using multiplication. Well, we could take our x times our x and our x times our 2 and we would get this. We've looked at solving problems like this before where we just have one logarithm and we need to try to solve it. Really all we have to do is to take our base here, swing it over, and it hits the 3 up as an exponent. In other words, we're putting it in the exponential form. Remember, when you put it in that form, the log drops. Your 2 cubed is 8. So let's subtract an 8 from both sides, and you realize it's just now quadratic. And if it's quadratic, you could use your quadratic formula, or you could try to factor it. In this case, it does factor into an x plus 4 and an x minus 2. You set the first parenthesis equal to 0 and solve it, and you get negative 4. Set the second one equal to 0 and solve it, and you get 2. Now, remember, whatever is after your log, this one, or this one over here, have to be positive. If I take my negative 4 and plug it in, it does not cause this to be positive. So I cannot use the negative 4. Can I use the 2? If I take 2 and plug it in up here, that's positive, and 2 plus 2 is positive. So my only answer would be 2, since what's after my log has to be positive, and so the negative 4 does not work. You'll notice here on the left we have one logarithm, but we have two logarithms on the right. On the right, you're going ahead and you're adding logs together. Remember, if you're adding a log plus a log, you can combine it together into one log. Combining it together into one log, you would have to multiply what's after your logs. So you take your 5 times your 3, which you know is 15. Since you have one log on the left, one log on the right, and they both have the same base, what's after them also has to be equal. So your parentheses here has to be equal to your parentheses here. Then it's pretty easy to solve by subtracting 2 and dividing by 3. And so you know that this right here is a little bit more than 4. Because 3 times 4 is 12. So it's a little bit more than 4. We want to check to see if this works. 3 times something a little more than 4 plus 2 is positive. And of course these over here are also positive. So that would work. We don't have to do anything more to check that. So if you have logs in all your terms, reduce each side to a single logarithm and then drop your logs. If not all the terms had logs, like the first one we did on this slide here, this one over here, we didn't have a log with a 3, reduce the whole equation down to a single logarithm and then put it in the exponential form. So here, not everything has logs, so we're going to try to reduce it down to one logarithm. You have a log plus a log, so you could write it as one log by multiplying what's afterwards. So in other words, we're taking this times this here, and that's how we get this. Once you have it as written as one log, you can take your base of 2, swing it over, hits the 4 up as an exponent. Then you realize it's just a quadratic equation again. Set it equal to 0, and then you could try to factor it or use a quadratic formula. It's going to factor into an x minus 8 and an x plus 2. Set each parenthesis equal to 0, and you get x to be 8, and you get x to be negative 2. But then you got to go ahead and check. Do these answers work? If I take this right here and plug it in here, is it positive? Yes. If I plug it in here and subtract 6, is that positive? Yes. However, if I come back and I try plugging in the negative 2, plugging in the negative 2 here puts it as a negative and it doesn't work. So we only are going to be using the 8 since the negative 2 causes you to get a negative after a log. Over here, everything has logs, so we're going to try to reduce each side to a single logarithm. You'll notice here we have a number in front of your log. Whenever you have a number in front of your log, you could take it up as an exponent. Then we still have a log minus a log on the left side. A log minus a log means you could write it as one logarithm, but you're going to end up by dividing the two things that are after your log. So you're going to take your x to the 4th divided by that 5. You only divide what's after the logs. Now, a single log on the left, single log on the right, the logs drop, and what's after your logs has to be equal. You realize now that, oh, it's a fraction equal to a fraction. So all you have to do is go ahead and cross multiply. This times this, and then this one times this one. And so then we get our 1 times our x to the 4th equaling our 5 times 125 over 625. Now we'll go ahead and take the 4th root. Remember, whenever you take an even root, you got to remember plus or minus. So we get 5 or negative 5. Then you want to check each one of your possible answers back into your original. Here we only had a variable occurring once after a logarithm, and you should realize if you put a negative 5 in there, it won't work. But if you put your positive 5 in, it would. So only 5 works since the negative 5 causes you to get a negative after your log.